All right, today we're going to talk about robot orientation. So here we're going to break down the many different types of industrial robotics or industrial robots, as well as look at some of the safety features and the equipment that we're going to be using throughout this progression of labs. So in thinking about industrial robots, there are many different types. The main big three that we're going to mention today is going to be an articulate robot. So those are the ones that look like an arm that's moving, doing material handling or welding. There's also delta robots. They're also known as a spider robot, where it's kind of like a 6-axis but flipped upside down, using a different articulated motion of the motors. And then there's also some newer robots coming out that are SCARA robots, where they're doing fast-paced pick-and-place sorting with a 3 and 4 axes. And then we also start seeing a lot more collaborative robots, where it's safe to be in the work cell with that specific robot. It has additional pressure sensors where it can tell whether something is bumping into it, or you can even actually push the robot away. So we're always really careful how we define collaborative robots. It's really, is it safe for an employee or a worker or a programmer to be in that work cell while the robot is running and using it to do some heavy lifting or some remedial tasks. Throughout this lab progression, we are going to focus on a 6-axis articulated robot doing material handling. So these are the type of robots that are doing fast-paced sorting, palletizing. Anytime you see a yellow FANUC robot, that's going to be doing material handling or welding. Anytime you see a gray robot, that's going to be doing a paint function, or paint or powder coating. And usually when you see a white robot, that's going to be used in either pharmaceuticals or even in food processing, just because there's a little bit more, take a little bit more care of the clean environment that it's in. And then of course, when you see a green robot, that's going to be collaborative, and you can tell that you can be safe to be in the work cell with it. So looking at our robot that we're working with throughout this progression, this is a FANUC LRmate 200 ID4S 6-axis robot. This is a real industrial robot built in what we call a CERT cart, or a CERT education work cell. CERT stands for Certified Education Robot Training. And with a piece of equipment like this, we can actually certify students in doing basic material handling, using an IR vision system that you see here. We can really do a lot of great programming activities, as well as getting people ready to work on the small palletizing robots at an operation, or the really big robots that can lift up a car. So it's the same controller, teach pendant, and robot technology that you see on all of those different types of FANUC articulated arm robots. When we say 6 axes, it's actually broken down, and you can think of it as kind of like your own body. So here we have 6 different joints. The first joint being here at the waist, second joint, third joint kind of moving up towards, think of it as like your elbow. Fourth joint would be your forearm, and then the fifth joint is being your wrist. The sixth joint is going to be the rotation of the wrist, so the end of arm tool that we have attached to this robot. So again, joint 1, think of it as your waist. Joint 2, your shoulder. Joint 3, your elbow. Joint 4, your forearm. Joint 5, your wrist. And then joint 6 is the rotation of the wrist. Right now, this robot is completely zeroed out, except for our 5th axis here. So there's actually witness marks at each of these individual joints where you can tell that this is the 0 home position. The reason that we put it the 5th axis, that wrist down, is something that we call singularity. We'll be able to touch on that a little bit later. But really, this is kind of our general home position in working with the robot. It's at rest. We use this as our home position register. The robot cart itself, we have it built in a collapsible table so that I can fit through a standard doorway. It has a transformer, so it can fit into a regular 120 volt outlet. There's an air compressor, quiet air compressor included to work with our end of arm tool gripper. as well as this robot has a second end-of-arm tool being a pneumatic suction cup. There's also a lot of safety that's built into this robot. One of the things that you'll notice, it's fenceless. It's an open work cell. That doesn't mean that there's no safety built in. There's actually an area scanner built underneath the cart so that when we're in full auto, that means the robot is running a program at 100% speed or however it's defined. As I approach the robot, I can see that there's an indicator light that says it's green. So right now the robot is safe to operate. It's going to move in that full auto program. But as I approach the cart, you're going to see that light is going to turn red, and that means I'm in a dangerous zone. This is where you'll see the robot stop. So the most important thing to remember is, yes, this is a robot cart built for education, but safety is still a huge priority. When we're working in teach mode and programming with the robots, we can get up close. We can take the teach pendant and get really close to the table, look at different angles, make sure we have the right perspective. But it's always important to remember that robots can injure you. There can be extremities caught in between joints. The robot, this is not a collaborative robot, so it can, if it's going to hit you in full auto, it's really going to hurt, could possibly injure you or even cause some serious brain damage. So we always want to be careful when we're working with the robot, making sure that as we're programming with it, we're in teach mode and we are using correct safety procedures. One of the other things that this robot has programmed built into it is something called DCS, or dual check safety. And what that means is there's been certain parameters, kind of like an invisible force field, built around each axis of the robot, as well as the cart itself. There's also a speed check parameter, so that we can't have the robot moving so fast that it shakes the cart. So when we put those parameters in, it really makes it safe to teach and work with this particular type of robot. To the teach pendant, the first thing I have to do though is I have to turn the robot controller into teach mode, so out of full auto. And I'm also going to turn my teach pendant on. And this way I'll be able to manipulate the robot using a few things on the teach pendant, and we're going to test out that dual check safety. When we're using the robot, we're going to use a couple different safety features. The first one is we cannot move this robot unless we press the Deadman switch. The Deadman switch is on the back here, and it's actually a two-way Deadman switch. There's two positions. There's one, and then there's two. The best way to think about this is if I hold it in position one, while also holding the shift button, I can rotate and I can manipulate the robot. If I let go of shift, the robot's going to stop. If I let go of that position one Deadman switch, the robot's going to stop, and I'm actually going to see a fault incur. The reason that it's a two-man, you have to think about if you are working with a large robot that is in a work cell, and you're moving that robot, and it actually pins you up against the wall and you squeeze in, that's also going to stop the robot. So in working with a Deadman switch, there are two positions. One, two. You want to hold it in the one position anytime you are jogging or moving the robot. So as I hold in the Deadman switch, hit reset to clear my fault, and then I can move the robot. Now as you can see, I'm moving it back towards the back of the cart. And this is where I'm going to run into that dual check safety, that DCS system. The DCS is actually going to prevent me from running into the back. And you'll see that there's an error status that comes into place. This is to protect the equipment. This is to protect the cart. This is also to make sure that students are being mindful of where the robot is at all times. The one thing that you have to do is when you are hitting the DCS, hit reset, and we can actually go back the same way that we came to get out of that DCS error. So that's a brief rundown of all the different safety features and the equipment and the robot that we were going to be working with today. You are going to see us working with an R30 IB Plus controller with the teach pendant here. and as well as working with RoboGuide programming software to interact with these different labs and doing hands-on work with the robot itself.